All right, we got our systems of equations test review test coming up on Friday, which should be tomorrow if you're watching this on Thursday. Um, Starting out with solving systems of equations. Number 1 and 2, we're using only the elimination method. So there might be other ways you could do it, but we're sticking with elimination method for number 1 and 2. In order for the elimination method to work, I need the coefficients of either the x or the y to match up. None of them do here. So we have to change one of the equations to make them match up. I'm going to take the bottom equation and multiply it by 2 because I want the y's to match up. That'll give me 2y on the bottom to match with 2y on top. So the top equation stays 3x plus 2y equals 10. The bottom equation is going to become 2x plus 2y equals 10. Don't forget to distribute the 2 across the equal sign as well. Now I have my 2y and 2y. So to make the y's eliminate, I need to subtract the whole bottom equation from the top equation. 3x minus 2x is 1x. 2y minus y eliminates, equals 10 minus 10 is 0. So it always kind of gets weird working with 0, but that is your x right there. X equals 0. That's half of our solution. We got to go back and find the y. So take any one of these equations. I want to take the original one. This looks to be the smallest, easiest. X plus y equals 5, but x is 0. So 0 plus y equals 5. Well, 0 isn't necessary there. 0 is nothing. It's just y equals 5. X is 0, y is 5, which can also be written as an ordered pair, like that. Number 2. Interesting looking problem here with this giant number, 4,781x plus 8y equals 16. But I notice the bottom has negative 4,781x. The positive and negative version of the same thing. I can eliminate that if I add these two equations together. So positive 4,000 plus negative 4,000 eliminates to give me no x's. 8y plus negative 6y is 2y. 16 plus negative 12 is 4. So if 2y equals 4, then y has to equal 2. That's half of my answer. I need to go back and find the x. So take either one of these equations. I guess the top one looks a little better because it's positive numbers. So 4,781x plus 8 times y, which we just found out is 2, is going to equal 16. We can solve that for x. Well, I know 8 times 2 is 16, so 4,781x plus 16 equals 16. Isolate the x here, minus 16 to both sides. 4,781x equals 0. So to get x by itself, divide 4781, divide 4781, and x equals 0. Another 0 problem there. You could also write this 0, 2. So there is elimination. Next, we have substitution. We got 3 of these using substitution. Again, you can solve these several different ways. We're going to stick with only substitution on these 3. On number 3, we have y equals 2x plus 3. 2y equals 4x plus 6. I'm going to go with this here. This is y, 2x plus 3. Anywhere else I see y, like down there, I can take out that y and replace it with what y is equal to, which is that right there. I'm going to say 2 times y. Instead of putting in y, I'm going to put in 2x. 2x plus 3 equals. So this is the exact same as 2y. 2 times y equals 4x plus 6. So I can now solve for y, or solve for x. I got a big equation with only x's in it. So distribute 4x plus 6 equals 4x plus 6. All right, interesting looking, but if I now get the x's together on the same side, cancel out by subtracting 4x, those cancel out, these also cancel out, 6 equals 6, which is always true. This is always true, then we're gonna have infinitely many solutions. So infinitely many solutions. What that means is these are the exact same 2 lines. If we were to graph these together, it's the same thing on top of each other. So any dot along those lines, any coordinate along that line is a solution to both x and y. Number 4, we got 3x plus 2y equals 96, and y equals x plus 8. They tell us here that y is equal to x plus 8. So in the other equation, where we have this y, I can remove the y. I can remove this y and replace it with x plus 8. So that will become 3x plus 2y equals 96. That y is now x plus 8. So big equation with only x in it, I can solve for x. 2x plus 16 when I distribute. So 3x plus 2x plus 16 equals 96. That's 5x plus 16 equals 96. Minus 16 to both sides, you get 5x equals 80. So divide by 5, and x equals 80 over 5 is 16. That's half my answer. Once I know that x is 16, I can now look at this equation right here and say that y is equal to x, which we just found is 16, plus 8. So y is now 24. So x is 16, y is 24. That's going to be 16, 24. Number 5, we got 2 equations that are both in y equals form. Well, same process as before. I can take this, which is y, and plug it into that y. So 15x plus 4 equals 5x plus 34. Now, I've had some of y'all ask me, why did I take this y, plug it in, instead of taking the other y, and plugging it in here? You could do that just the same. If we did that, we would end up with 5x plus 34 equals 15x plus 4. So it's the same thing, but it would be in opposite order. So same equation either way. To solve this now, I got an x on both sides of the equal sign. I'm going to cancel out the smaller x. That gives me 10x plus 4 equals 34. Minus 4 to both sides. 10x equals 30, which means x equals 3. Now I need to find what y is. This here tells me that y is equal to 5x plus 34. Well, if x is 3, 5 times 3 plus 34, which is 15 plus 34. So y is equal to 49. 3 comma 49 would also be how to write that. 6, 7, 8, and 9. Solve 6 through 9 using any method. So you could choose elimination, you could choose substitution, you could even choose graphing on Desmos. So yes, on the test you can use Desmos. There is one question on the test where you have to use the actual graph given to you. So you're going to have a graph sort of like that, and some equations sort of like that, where you have to graph them. So number 6, I'm going to do it that way just to kind of remind you what to do. You don't have a graph like that on your test, so you don't have to worry about it, but at least on this video, I'm going to do that. Negative 2x minus 4 is there. Slope of negative 2 is down to over 1. So it's going to look like this. There's the first one. Y equals x plus 5 is going to look like minus 5 with a slope of 1x, so like that. Look like that. There's my solution. Negative 1, 2, 3, comma 2. Negative 3, comma 2. There's one on your test that you have to use that. Everything else, if it were me, I would use Desmos. So 5x plus 1.7y equals 25. I go to Desmos. 5x plus 1.7y equals, I don't remember what it equals, 25. So equals 25. That gives me this red line. Next equation. 1.7y equals 3x minus 15. 1.7y equals 3x minus 15. So here are my two lines. I can tell where they intersect right there at 5, 0. So there's your answer, 5, 0. Number 8, x minus 2y equals 3, 2x minus 4y equals 6. X minus 2y equals 3, and 2x minus 4y equals 6. So, I don't know if you can see what happened right there, but it put the purple line directly on top of the green line. So where do those two lines intersect? Everywhere. So our answer there is infinitely many solutions. Number 9, 2x plus 3y equals 6. 2x plus 3y equals 6. 2x equals 18 plus 2y. 2x 18 plus 2, whoa, not y, 2y. So I see they intersect. Oh, that's ugly. 6.6 comma negative 2.4. 6.6 comma negative 2.4. Remember, this is your value of x, and that's your value of y. Number 10. This is a new one. That was for number 6 up there, so ignore that. Here we have a system of inequalities. We learned inequalities last unit. That's where you have the less thans and you have a dotted line and shade below or whatever. We've done inequalities, we've done systems of equations, now we're combining the two together. So, circle the ordered pairs that are solutions to the following system of inequalities. First, we're going to graph it. I can graph y is less than or equal to 3x minus 2. Start with my y-intercept minus 2. My slope is 3. So there's that line. This is less than or equal to, which means solid line, shade below. So there's that. Shade below. The red line, we have y is greater than 1/4 x plus 2. There's my y-intercept of plus 2. Slope of 1/4, that is greater than. That tells me dotted line shaded above. Dotted line shaded above. Highlight that. It's going to look sort of like that. Now, what's going on here? If you remember what's happening up here in 1 through 9, you're trying to find the one point. Let's think of number 6, for example. There are an infinite amount of x's and y's in that equation. There's an infinite amount of x's and y's in that equation. We're trying to find the one x and y that's in common with both of them. One spot where it overlaps. Remember when we learned this, boys had an equation, girls had an equation. There was one point that overlapped. Well, here it's similar. There's a whole bunch of points in this shaded area. There's a whole bunch of points in this shaded area. I'm looking for a solution, which is the points that are in both shaded areas. So if I look at my graph, look at where the shading overlaps, and it's this blue section in the top right. That's where both shaded areas overlap. Any ordered pair up there is a solution. So point A is 3, 1. Not a solution. Point B, -2, -3. Not a solution. Point C, 4, 6. 4, 1, 2, 3, 4, 5, 6. That one is a solution. There may be more than one, it says, so keep going. 4, 3. 1, 2, 3, 4. 1, 2, 3. That is on a dotted line. So, not a solution. -1, 4. -1. Now, it's a solution to the purple one, but not to the blue one. Not a solution. 1, 1 is right there. Not a solution. So there is only one ordered pair, which is 4, 6. You can also do this problem on Desmos. I'm going to show you real quick what it looks like on Desmos. Okay, I went ahead and paused it, graphed these, so you don't have to watch me take all the time to do it. I graphed 2 lines. We got line A, which is the red one, line B, which is the blue one. It shades it for me. And then I even plotted all the ordered pairs on here and labeled them A, B, C, D, E, F. If you look over here now, you can see point A is in the red but not the blue. Point B is in none of them. Point C is in both of them, red and blue. Point D is on the dotted line. Now, if that was a solid line, it'd be good. But being dotted, it's not. That's the equal to, and it's not equal to, it's only greater than, so not a point or not a solution. E is over here in one, but not the other. F is on one of the lines, but not the blue. It's not in the blue shaded. So our only solution is point C there. Moving on to number 11. We're writing a system of equations and solving. A Sonic cheeseburger is $3.79. A classic chicken sandwich is $4.09. I bought twice as many chicken sandwiches as cheeseburgers, and the total cost was $95.76. How many of each sandwich did I buy? So there's my question. How many did I buy? I have 2 unknowns, 2 variables. In this situation, I don't know how many cheeseburgers. I'm going to call those, let's call them B for burgers. And I have chicken sandwiches. We're going to call that, let's go S for sandwiches. So B costs $3.79. S costs $4.09. I know that my total cost was $95.76. So something is going to equal $95.76. Well, I spent money on the burgers. That was $3.79 each. So 3.79 times B. Plus, I spent money on the chicken sandwiches. It's 4.09 S. which is going to equal 9576. There's one equation. My other equation, I buy twice as many chicken sandwiches, that's S, twice as many S's as B's. So how many S's did I buy? I bought twice as many as the burgers. That is our system of equations, but now we need to solve it. We could choose substitution, we could choose elimination, or we can choose Desmos. In this case, with all these ugly decimals, I'm going to go with Desmos. So I cannot graph S's and B's in Desmos. I have to have X's and Y's. So we can't forget which one is which. I'm going to make the B be my X, and I'm going to make the S be my Y. So whenever I go type it in, I have to make sure I keep these straight. Replace B with X, replace S with Y. So when I graph both of those equations, this is what I see. I see my Y equals 2X, that's the black line here. I don't see the purple line though, but it's got big numbers in it. It goes up to 95. So zoom out and you'll see where they intersect. That intersection point right there is going to be 8.061 and 16.121. Uh-oh, that doesn't sound right. I can't buy a decimal number. Wait a minute. I see a mistake. Because chicken sandwiches are 379, not 370. I had a typo. 379. Now, there we go. My intersection point is 8, 16. So let's come back here. We have the solution is 8, 16. This is my X. This is my Y. My X was B, which is cheeseburgers. So 8 cheeseburgers, and 16 is my Y. Y is my S. S is chicken sandwiches. So 16 chicken sandwiches. So I know that's sloppy. My bad. Deal with it. 8 cheeseburgers, 16 chicken sandwiches. Number 12. You haven't seen questions like this before, but I'm assuming you'll be able to figure it out. We have two functions that are described in the tables below. So far, I've only given you functions in equation form. Now I'm giving you functions in table form. We have x and y1 and x and y2. If you remember what our whole purpose here is, when we solve a system of equations, think about the very first day. We had the boys' equation where they found an infinite number of solutions to their equation. The girls found an infinite number of solutions to their equation. Our solution was the one ordered pair that they had in common. So, if I look at these two tables, do I have any ordered pairs in common? I see 12,2 and 12,2. Yes, I do have that in common. There's my solution, 12, 2. Number 13. Same thing, two functions are described below. I see 2, 18 and 2, 18. My solution, 2, 18. So easy questions, as long as you can figure out what's going on. 14 through 17, we have some word problems, but you're not solving. So we're only writing here, not solving. Number 14, at a restaurant, the cost for a breakfast taco and a small glass of milk is $2.10. Well, call T the taco, M the milk. So one breakfast taco and one milk is $2.10. I'm going to pause there and look. Oh, never mind. I was going to say we can look at our answer choices and see what we can eliminate. But they all have T plus M is 210. So that equation helps us out with nothing. The other sentence, the other equation, the cost for 2 tacos and 3 milks is $5.15. So 2 tacos and 2 milks. It's not it. 3 tacos and 3 milks. Not that. 3 tacos. It's not that. It is going to be choice D. Number 15, the Frosty Ice Cream Shop sells sundaes for $2, banana splits for $3 on a hot summer day. So let's see. S here is $2. Let's go with B is $3, just so we can keep our thing straight. I'm going to go color code it. On a hot summer day, the shop sold 8 more sundaes than banana splits. How many sundaes did they sell? What does S equal? 8 more than banana splits. So banana split plus 8. I see that one has it. S plus B equals 8. That's not right. S equals B plus 156. That's not right. B minus S equals 8. Well, if there's 8 more sundaes, that could, actually S minus B could be right, but B minus S, I already know what my answer is going to be. But just to double check, we're going to go on and work the rest of the problem. They made $156. So where did they make this money from? Well, every S they sold was $2, and every B they sold was $3. So 2S plus 3B is 156. Answer choice A. Number 16. At a college bookstore, Carla purchased a math textbook and a novel that cost a total of $54, not including tax. So a math textbook and a novel is $54. If the price of the math textbook, M, is how much? 8 more than 3 times the price of the novel. 8 more than 3 times the price of the novel. So that's one sentence. Which system of linear equations could be used? Well, the other one is the cost of just one math textbook and one novel was $54. So a math book plus a novel equals $154. And it's not 8. It looks like it might be H, because that equation is good. Look at the bottom one though. They have 3n plus 8. I had 8 plus 3n. It's a little bit different, but that looks like it's the exact same. You can add in any order. Here we're subtracting 54. That's not going to be anything right. And m plus n equals 54. That's not right. So it's going to be H. 17. Chase and Sarah went to the candy store. Chase bought 5 pieces of fudge and 3 pieces of bubble gum. So we have F and G for a total price of $5.70. So I can already see what's going on here. 5 pieces of fudge. So 5F plus 3 pieces of gum equals 570. Can I eliminate anything here? 5F plus 3G is 360. Well, no, it's 570. That's not right. 7F, I don't even know where these numbers are coming from. That doesn't look right. 5 pieces of fudge. 2 gums is 570. That looks good. 5 pieces of fudge and 3 gums is 570. That looks good. So it's either G or J. Well, that was Chase. Sarah then went and bought 2 pieces of fudge. So we have 2F plus, what else did Sarah get? 10 pieces of bubble gum for a total of 360. So that is, it's off by 1 fudge. Here we got 2 fudges and 10 gums. It's going to be J. So you're not really doing any math here on these 4 problems. You're just translating what they have there. So that's everything. The test should be very simple, straightforward. If you can do this review, you can do the test. Something I didn't mention. let's go back to look at number 1 through 5. You do have to actually use my method that I give you to solve these, but there's no reason why you can't go over to Desmos while you're taking your test, graph those two to see what the answer should be. If I graph those and I already know the answer has to be 0, 5, it could help me quite a bit along the way doing this whole elimination process if I already know what the answer is. So get your answer from Desmos or check your answer on Desmos. Just because you have to use elimination doesn't mean you can't also use Desmos. Good luck.